Hi to all, welcome to this new tutorial on ixCube 2.2.3, and today I just want to show how to run a structural analysis over this model and check the membrane stresses and the steel efforts with the BS checker or the Eurocode checker. Well, here we have done a very simple shape. It's balanced, and we have 3 loads: wind uplift, wind down, and lift load. And we want to run now the structural analysis. The loads are quite high. Here we fill in the load cases with the factors for these loads, and generally we have here 1.35, 1.35, 1.35, then we have 1.5 here, 1.5 here, and 1.5 here. Cases that have to fit with your country codes. Again, here we go into the analysis settings, and the accuracy of the analysis is controlled by these 3 numbers. So if between 2 successive load steps the difference in energy between 2 steps is bigger than this value, the solver will stop with a convergence error. The same is for the displacements, and the same for unbalanced forces. The reason why we leave displacements to 1, since displacements generally are very high. So to get convergence we need to put generally at least 25 here. In this case now I have 35 steps, and that means that the load will be split into 35 small loads and applied on the structure. So 1/35 part of a load will be applied at each step. Within each step, a number of iterations are performed, converge the unbalanced forces, the displacements, and the energy to this accuracy. So we want to run all 3 load cases. We just run all, and we see if the solver is going to convergence. We will see here all the data about convergence criteria. I just have to wait that it ends up. That's it. So after the analysis, we will see for each load case this file will tell us if converged or not. In this case we have all converged. The first thing that we want to do now is to check the stresses of the membrane. So we will go into the first load case, and easily we can check the membrane stresses. We take off in the plot ranges, we take off the automatic scaling, and now we input as the minimum stress 0 and the maximum stress the working stress of the membrane. In our case the working stress of the membrane is 16 kilonewtons per meter, since we are using a very pre-contained 702, and then we just click on an update. We have to click yes. The response, we want to see the membrane. We can use the von Mises stresses, and so easily you can see that the stresses for load case number 1 have a maximum of 3 kilonewtons per meter, and so on the range. Load case number 2, again we have 7 kilonewtons per meter, and this red area, this area here. And load case number 3 we have again 4 kilonewtons per meter. So the membrane is not overstressed. It's a good idea to check reaction forces to see that the model has been well defined. We will see floating reaction forces, so unbalanced forces here in parts of the structure not fix it to the ground, and this means that we have big unbalanced vectors, or we have some error in the modeling of the structure. And last, we want to check the steel elements. If we go here, we can see that the columns are in this group here, column, and this is the horizontal beam, and so on. To check the steel, we go into the British standard checker. So here we will check the steel against the British standards. We click here for the number of loads for which we want to check, and into the model, a double click will load the data into the checker. So in this moment we are checking the column group, and we see here all the elements loaded from the group. We have the type of element, it's a beam, the number of segments, these beams are made by one element, and this is the cross section, it's a pipe, the technology used, and all the data, the input data. We just recall here check, and all the elements are checked against all these load cases. So a green line means that it has passed all the verification rules, and we can see here the safety factor of the element. A number bigger than 1 is okay, so bigger this number is, it means that the element can be reduced inside, so the steel can be optimized. A number less than 1 means that the element is not verified. In the bottom table, we can see the checks for the strength for all the load cases and for all the points that have been checked. At the end, we find here the safety factor for that particular check. Then we have the buckling analysis, the buckling checker, and the buckling checker will skip, of course, elements in tension and will check only compression buckling, and again the safety factor for the element. So once we are satisfied with this checking, we can create a report, generate a report. We can create a detailed report if you want, or a synthetic report, and generate this report. Here it is, a report where all the elements, in this case I have selected the synthetic report, so one row for each element is printed, and you'll find the beam code, the section of the beam, and the load case for which the safety factor has been generated. The minimum safety factor in this case is 4.7, and all the numbers of that check. The same happens for the buckling check, and so the beam element, the number, the cross section, and the load case number 1 in this case has generated the smallest safety factor. So that's quite simple. If you want to check for another group, you can just double click to load the group and run again the checker. You see here that it has passed both the strength checking and the buckling checking. Of course, well, that's quite okay. You can see here that the safety factor is quite big, so maybe we can reduce the pipe. We can choose another pipe if we want, like this. In this case the row becomes white, it means it needs to be checked again, so we can check it. Here it is, and you see that the safety factor has been reduced from 4 to 2. So for this element we can use a pipe 3. Of course, after changing here the parameters of the steel elements, we need to run again the structural analysis because the stiffness of the structure has changed, and go back and recheck, of course, the elements. So that was a quite fast and easy tutorial. Thanks for watching.